All right, 2.2 is a fairly short section. It's just a real quick on being able to read and sort of understand how variables sort of relate graphically, and we kind of look at those different cases, and we'll start off with the scatter plot and we'll work from there. All right, so a scatter plot is a graph consisting of individual points. So the individual points would be some x value paired with some y value. So it'd be some x, y, and so each individual point would represent a single x value and a single y value. And then we'd plot them all together. And what you do is you sort of look for patterns in scatter plots. All right, so what do you see? What's the pattern? And so in this case, there's a couple things you should see. First of all, you should note that there is this point out here that kind of lies all by itself. All right, it's not really a part of the pattern of all of the other points. If you look at all of the other points kind of land here and steadily kind of go up in this shape. Now they're like all around that line that I drew, but they're all together. Now there is this singular sort of what we'd consider that would be called an outlier. It's outside most of the data value points. It's not a part of the pattern, but it's there, so it's again important to make note of. The rest of them seem to be in an increasing, and it looks like it's a fairly steep increase. So the pattern would be the points, right, as my x values get bigger, right, as I'm going out here and they're getting bigger, the points, which would represent the y values, also get bigger, right? And so this would mean that it's an increasing pattern. Increasing. It has a positive correlation. As one value gets bigger, so does the other. As the x values get bigger, so do the y values. All right, and this one actually follows that. It just is extreme in that case. It's a little slower in all of the other cases. So again, it's a sort of a steady increase of my plotted points. And so again, when you're looking at scatter plots, you can understand what does it look like. And it does look like there is a relationship because the points aren't, other than the one, they aren't really far away from each other. They do follow a pattern. Looking at the next example, though, this is what we would consider scattered. This is just a scatter plot. If you look at this, there's no real pattern to it. Unlike the last example, there's no real pattern. Right? It sort of goes up, then it goes down, then it goes up. They kind of stay there again. Boom, 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 boom. It's like all over the place. There's no real pattern to it. All right, there's no steady increase. Sometimes it goes up, sometimes it goes down, sometimes it goes up by a lot. And so this is what we truly say. This is just a scattered plot of points with little to no correlation. All right, there's no pattern. They're not steadily increasing. They're not steadily decreasing. All right, they're just scattered all over the place. Right, they're all over the place. All right, so the next example, we're going to look at actually a table of values that we've plotted. All right, so the example in the next set of notes here. All right, so we've got some data here. All right, so we've got the year and the number of driver's license that were handed out. So we've got the number of driver's license in the United States that were given out every year. So just to keep it in mind, there's about 350 million people in the U.S., and again, that counts everybody. And so you think about this, how many people are over the age of 16? And not everybody gets a driver's license. Most people do, but not everybody does. All right, so in 1980, about 145.3 million people had a driver's license. 1990, 167, and so on to 2012, which there was 211.9 people had a driver's license. And again, you look at the numbers here, as the time goes up, the numbers go up. And so if you go, and so the data here was plot. Each one of those points represented X and Y. X would be the year, which would be the independent value. Y would be the number of driver's license. The number of driver's license depended on my year. So this first point would represent 1980 and 145.3 million people with driver's license. And again, each one of those points would represent, so this last point would represent the 2012, which 211.9 million people, and then everything in between, all right? So those are all of the plotted all of those points on the graph. All right, so what does the graph tell you? So if you look at the graph, and even you can use the numbers in the table, right? Over the years, the number of people with driver's license has steadily increased, right? It's gone up sort of pretty close to a steady increase. Even between the last couple of years, it went up. It didn't go up by much, but again, there wasn't a whole big time period there. There's only 2 years between 2010 and 2012. Versus the rest of them, there's 10 years. So there's 10 years between 1980, 1990, 1990, 2000, 2010, which those went steadily up. And then the last year, it went up. But just note, those two dots are closer together because those only changed by 2 years. All right, so the graph tells you. And again, you can put this on your learn in your own words. All right, it looks like the number of driver's license has steadily increased over the years 1980 to 2012. All right, again, it looks like a pretty steady increase. All right, it would be pretty good. You could say that it correlates over time. The number of driver's license has increased, right? That would be a pretty good, again, correlations over time. It's been pretty steady. All right, so the next one we're going to look at is we're going to look at the same table, but we're going to make it into a line graph. So this was a scatter plot because it's just points that we've plotted together. In the next one, we're going to connect the dots using lines and look at, and sometimes it's helpful to do that because that gives you a better idea of kind of what's happening over the years. All right, so we're going to connect the dots. So we get to a line graph. So we go from a scatter plot to a line graph. A line graph is when we're connecting the adjacent dots using straight line segments. So between each dot, we draw a straight line. All right, so we draw a straight line from point 1 to point 2, point 2 to point 3, and so on. So using the previous table for the number of driver's license, there's my points for each year that we've plotted. That represents the millions of driver's license. And then we've connected the dots between each of the years. So we draw a single line from point 1 to point 2 to point 3, 3 to 4, and so on. And sometimes, again, like I said, it gives you sort of a better representation of what's kind of going on over the years. All right, so, again, it does look like, again, this is easier to tell. I said it in the last example, but it does look like it's a pretty steady, pretty much the same, right? That's what I mean by steady, increase in the number of drivers. Now, the last bit doesn't increase as much, but remember, there's not as much time that goes by. There's only 2 years of time between the last segment, whereas all the previous segments, there were 10 years. All right, so who's to say that in 2020 there wasn't still the same increase going all the way to 2020? All right, so now we're going to kind of correlate to what we did in 2.1 and 2.2. So we're going to find the percentage. We're going to use interpolation and extrapolation again. So this is sort of a throwback question to reading the line graph and finding our changes. All right, so first the percent increase in driver's license from 1980 to 2012. So we're going to use 1980 and 2012. So over the entire time period. So remember, percent change is we take the change over the years divided by the starting year. So we're going to take the 2011.8 minus the 45.3. Remember, it's in millions. Divided by the starting point. The starting point, we started with 145.3, again in millions. All right, so when we do the division, we have to remember we're looking for percent, so also don't forget to multiply by the percent. So again, change in value, change in function value, divided by the starting value times your percent. And so when we multiply that all out, it comes out to 45.76, so 45.8% change, increase. All right, so it was a pretty big increase over the 1980 to the 2012, right? 45.8% increase over those years. All right, the next one we're going to look at is the interpolation, if I can say that word right. Alright, so we're going to estimate the number of driver's licenses. We're going to guess what the number of drivers using the information provided for 2008. So remember, interpolation, which means we need to find between what points is 2008 land. Well, 2008 lands between 2000 and 2010. So these are the points we're going to use for our next example, for the interpolation to estimate. Alright, so first thing we do is we find the average rate of change over the 2000 to 2010. And so remember, average rate of change is the change in my function over the change in time. So the change in the function value was 210.1 million, 190.6 million. Alright, let's make sure I write those down right. 10.1 minus 190.6 over the change in time, which would be going from 2010 to 2000. So over the 10-year period, so there's a 10-year period. Alright, so the average rate of change comes out to be $1.95 million. Remember, it's in millions per year. So on average, between the years 2000 and 2010, the number of driver's licenses grew by about almost 2 million, 1.95 million per year. Okay, so the next thing we're going to do is we're going to use that to predict 2008. Well, 2008, we start with 2000. And then we're going to add the average rate of change 8 times, right? Because, again, 2000 to 2008 adds it 8 times. So 2000, we had 190.6 million plus 8 times the growth rate. Comes out to be $206.2 million in 2008. Again, it's an estimate based on the average rate of change, but we're going to estimate there's about 2.06 million driver's licenses in 2008. All right, now extrapolation. So 2017, so again, we're going to use the last 2 endpoints, so now we're going to go here. And again, 2017 would be over here, which would be 5 years, 5 years. 5 years after 2012. So keep that in mind. So we're going to use 2010, 2012 to estimate 2017, which is 5 years after 2012. All right, so first thing, though, we need to find is the average rate of change from 2010 to 2012, so over that 2-year period. All right, so 2012 was 211.8. 2010 was 210.1. Alright, so 1.8 divided by 2, so that comes out to 0.9. Remember, million people per year. Alright, so 2017, we start, in this case, with the ending year, which is 2012. And then this is 5 years after. And so we're going to take the 2012 amount, which was 0.8, add to that 5 times the average rate of change, which was 0.9 million. So we're going to take the 5 times 0.9, add to it the 211.8, comes out to be 216.3 million would be the estimated number of driver's license in 2017. Alright, we'll stop there. We'll pick up the next set of notes in the next video. So again, that was sort of a reading the line graph and throwing back to the similar questions that we did in 2.1. So it was sort of a throwback question.